Okay, folks. This recording was done because the first recording failed when I actually had class. So I'm going to go ahead and do a brief one. And that actually makes sense because when we're coding it all in, we spend a lot of time in the video just waiting on those people. So just look at this, pause it when you need to enter code or not. You stopped at 54 last time in slide 54 where we used the acceleration. Remember, acceleration is a change in velocity. All right. And velocity has both magnitude and direction. You change any of those things, you get a change in acceleration. And it can result with mass, you can feel a force. When your car's driving down the road, it's going 60 miles an hour, you're not changing direction, you're not changing the throttle at all in the car. You don't feel any force. But if you stop, if you hit the gas and really spike it, or if you turn, you'll feel forces. So those are all forms you feel the acceleration. So we get the accelerator and raw data, X, Y, and Z. We round it off, and then we print it out. This all shows up on the screen, the display of your Raspberry Pi. And you can see, again, we do our imports here too. Don't mean to jump that stuff. Then you should see values on your display between -1 and 1. Z only changes if you flip the whole Raspberry Pi over. All right, if you know where it is, the orientation of it, you could display some of the matrix and then continuously check which way around the board is and then update the orientation of the display. In other words, if I have a letter, in this case J, and I keep rotating it, the J should jump around the screen. And that's exactly what this next one does. From SenseHat, import SenseHat. There's your sense. There's the object you have to make with that function. Show the letter J. All right, now we're getting raw data for both X, Y, and Z. And we're going to round them. There's X round, Y round. And with that, we set Y, if it's -1, we set the rotation to 180. If that was X, excuse me. Y, else if, see this is Fx, then we go else if, we're used to else if, ELSEF, but in Python it's ELIF. If Y is 1, set the rotation to 90. Sorry, I don't like it down there. If LFY is -1, set the rotation to 270. Else, in other words, it's not any of those values, don't do anything. All right? So take a moment here. You can pause and type this out and get this to run. Save it. You can just call it a simple name. Save it and run it. Go ahead and pause your screen right now. I'm going to count to 3. Okay, you've hopefully paused it. Now you've put in the code, you've run it. Let's go to the next slide. All right, remember, by using else cases, we catch all those other situations. So the F catches the situations and else F catches, sorry about this arrow coming out. The F catches the first thing we test. The else ifs test each other's situation. But you got -1 here, 1, and -1. You're expecting those. What happens? You get something else that's not what you're expecting. That's what you grab with the else statement. The else is like collects anything you didn't get. All right. All right. If the board is only rotated, we'd only experience 1 G of acceleration. All right. If we shake it, we get more than 1 G. And, don't confuse that with a gram. That's a G is a measure of acceleration. And it's basically gravity. It's our gravity, acceleration due to gravity. 9.8 meters per second squared kind of thing. All right? Now, this next program, we're going to use the absolute function. And really what we're going to do is get rid of negative values because we don't care. We don't care if it's positive or negative on this. So that's when you use the absolute function. It's not specific to the SenseHat library. You can get it when you just use regular Python. Okay? All we want to know is when is our SenseHat being shaken? When is our Raspberry Pi being shaken? This is really useful if there was a wreck or something on the space shuttle and they had it on there. Excuse me, the International Space Station. We don't fly the space shuttle anymore. All right, from SenseHat, import SenseHat. You've seen that before. Sense equals SenseHat. Again, notice I set it to red. the value red, 255.00. While true, colon. Again, we've got the loop. Remember to be 4 spaces in. Acceleration gets sense.get accelerometer raw. There's the x, y, and z. There's the absolute functions of these. So it's going to give us absolute, and then we're going to test it again. Hey, if this is 1, or y1, or z1, show the letter I, and an exclamation point, or clear it. So in other words, if I get more than 1 in acceleration at any time, put out that red exclamation point. You really do need your Raspberry Pi to do this one. So I'm going to go into 3, and then you go ahead and pause it, and then hit play after you're done with 3, and then I'm going to go on to the next question for you. So 1, 2, 3, pause it, and do it. Okay, now, why not also, can you figure out a way to display the data on your screen? This only shows a red letter exclamation point on your Raspberry Pi when it's above 1. How about seeing the actual values? I'm going to challenge you to figure that out, and then I'll show you the solution. So at the end, I'm going to count to 3, pause, and then start it back up once you've tried it. 1, 2, 3, pause. Okay. If you went back to the last program, we could do basically what we did before. We have round, sorry, with the arrow doing that. Round x0, round y0, and then print it. So as it's testing for that letter I, you can also be assigning those values using the print command. And this is very similar to what we did just two programs before. All right. Okay. Now, let's put it all together. Let's make a game where astronauts can test reflexes, or you can test your friend's reflexes. The game will display an arrow LED matrix and select a random orientation for us. So it's going to take an arrow, it's going to be on your LED matrix. The player must rotate the board to match the arrow. If they match in time, the arrow turns green and the score increases. If not, the arrow turns red and the game ends, telling them to score. The game keeps showing arrows in new orientations until the player loses and each turn gets faster. This idea combines showing messages image on an LED matrix, setting and detecting orientation, use of variables, randomization, iteration, and selection. I'm not sure randomization is spelled S-A. I think that's Z-A-T-N. All right. As this is more complicated than those previous programs, let's use pseudocode. Let me just say again, as someone, I was getting these program competitions at a local makerspace type place, and the really great programmers always didn't start typing on the computer like most everybody else in the room did. They said, take notes, think about it, maybe read a little bit of book on it. They may even do this while they're drinking a cup of coffee. And the whole time we're typing away and keying away, I guess, and they would sit down, key, know what they're doing, get theirs to run first, get theirs to debug better, and they would end up winning. All right, so you have import the required libraries, SenseHat, SenseTime, random. That's going to be the first thing. We're going to have to create a sense object, but you've been doing this the whole time. Time and random are newer libraries because we're going to delay some things and create some randomness. Set up the colors we needed. Again, we're using British, so we got colors spelled. They're funny way of spelling it. Create 3 different arrows: white, green, red. White when you start, green if they get it right, red if they get it wrong. Set a variable pause to 3. So you have a variable pause equal to 3. Score and angle to 0. Variable play, set that to true. All right. Begin a loop while continue to play, true. Set a random angle, use random choice method, which you didn't know, but that's what I'm giving you now. Show white arrow and sleep for current pause length. Check whether the orientation matches the arrow. If it does, then add a point and turn the arrow green. Otherwise, set play to false, turn the arrow red. Shorten the pause duration slightly. Pause before the next arrow. And display the message once they exit it with a score. Okay? So, can you pause this for a second? And when I count to 3, pause it. See if you can do the very beginning of this. Import the libraries, create a sense object, and set the colors as needed. You may not remember how to make white, red, green, and red. See if you can. I'm going to pause it. 1, 2, 3, pause. All right. Hopefully you did it. So this is what that opening code would look like. From SenseHat, import SenseHat. From time, import sleep. From random, import choice. All right. And if you didn't know that, it's not the end of the world. Sense equals SenseHat. By now, you should probably know that. Now, white is just 150, 150, 150. Green is 255. Red is 255. Blue at the other end would be 255 as well. And then empty is 000. Create 3 different colored arrows. I'm going to count 3 and pauses. Go ahead and take a few minutes to type this out so you get your arrow looking structures. 1, 2, 3, pause. All right, then make your 3rd green arrow up here. Here's where you define the variables we just talked about. Pause, score, and angle, both set it through and true. And show a message. Keep the arrow pointing up. Scroll speed is 0.05. Text color 100, 100, 100. All right. Go ahead and type this out. I'm going to pause in 3. 1, 2, 3, pause. Okay, this is the last thing we're going to go ahead and get done, and you'll be caught up with the rest of the class. While play, last angle equals angle. While angle is equal to last angle, angle choice 0, 90, 180, 270. They're picking up choices in an array there. Hang loose. This is all going to make more sense in a little bit when you come to class Wednesday. Remember, we have a lab this Thursday or Saturday if you're a Saturday person. SenseHat, rotation, parentheses, angle, parenthesis, set, underline pixels, / arrow, sleep, pause. All right. So go ahead, put that, do that now, and you'll be all set to go for Wednesday. So go ahead. We're going to go ahead and pause it. 1, 2, 3, pause. All right. Hopefully you've just done this last bit of this. You're all set. You're caught up for Wednesday. Have a good one now. See you Wednesday.